In this video we want to have a look on the airflow on the surface from the X-wing and also from the VTOL jet, and also there is a little bit tuning and research. Now let's go into the video. To make the airflow visible in our XC30, I'm preparing some strands, some wool strands, and I will put now on the wings. Meanwhile, the camera holders are getting printed. Here, there, and also the ender is one. Testing them first time in lightweight PLA to get a little bit lighter. And here it is, ready, prepared. Let's see how it works. Yeah. Also the FPV plate is getting prepared. This is included in the set, in the STL set, so you all can install it as well. And here will be placed the DJI mini camera. Oh, I'm looking so forward to flying this first time FPV. And of course also the VTOL jet will come with me. Today is wonderful weather, sun is shining, super spring weather. So let's go on. Print parts are ready. Also here. And ready for installation. The XC40 is ready equipped. The VTOL jet is prepared, first time flying with camera. And on the XC40 the battery moved much more to the rear. And here I built a little stopper on the front that the battery keeps the position. So the CG is the same. And let's go to the airfield. So it is good visible that right from the start all wool strands are nicely aligned. Just there's two on the wings, but they stick on the tape. This is not cause of the airflow. This is cause of some sticky tape. And also the ones on the canards in the front, there is one sticking on the surface. That's why it is curved. And you can see almost on the very outside from the canard and between the both wings, there's a little bit turbulent air. And here I'm doing some stall maneuver. They are all wools are wobbling around, so this is because the airspeed is quite zero at the moment. I'm stalling with high alpha, and we can see that the jet is still super stable, doesn't spin. And when I give a little bit thrust, all strands are again aligned. And what is also interesting, that these outer strands stay as long on the surface. So when I start stalling or reduce the speed, the airspeed too much, then we see that the inside, also the fuselage and on the inner wing, the strands start wobbling and lift a little bit up from the surface. So this means disconnected airflow. And on the outside, like we saw here immediately, the very outer wools, they really stay very long on the surface. And this is the main reason why there is no tip stalling and no spin tendency. Here I'm again full pull in elevator, you can see it. And again all the wools are wobbling around. The jet is it's just going downwards with a little bit nose up, and after a little thrust, the airflow and the lift is working again. So this is a wonderful behavior, very easy to fly behavior. Here we can see it from the outside again. I'm flying with about a 45-degree angle of attack, so very high alpha. And with this needs about 60% throttle, so there is always enough safety to save the plane from getting down. And when I go to full throttle, I can accelerate it again and have normal lift and can go on flying. So this, it's a very beginner-friendly airplane. Also here, when I fly tight turns, There is a little bit loss of the lift. Starts always on the inside. Cause this was my vertical landing. I think this could be better. And in between was some time for flying the VTOL jet again. David is installing the FPV tech. What is this for a camera and transmitter?
DJI Air Unit 04.
Yeah. Okay, it's super small.
Yeah, the light version.
And we will attach it with a cable tie.
Ja, fliegt ja, offensichtlich fliegt das Teil. So, ich nehme dich jetzt auch aufgenommen.
Yeah, this was my very first time flying FPV at all, and David did the first start with the XC40 to check everything, and after this I give it a try, and it was just wonderful. This XC40 jet flies so easy, so there was never any dangerous situation, and with this FPV cam you can fly much far away and also in a very low level without any hesitation. And we put the small wool in front. This was more visible in the goggles than here on this picture. This wool was a little bit indicator for the airspeed. When we fly too slow, then it goes up, and when the speed is quite right, then it was straight, like you can see it here. And as next we tried a chase. David was flying FPV chase plane, his Delta, and interestingly, when I was flying upside down, like you can see here, we got really the best footage. The airspeed of both planes fit best. Yeah, even this was not that easy to fly, this upside down, but it is super neutral. The XC40, and also here you can see all the strands are lying good aligned on the surface, and David has some fun to get closer and closer. Even the weather was wonderful, just a little wind, and so we saw this XC40 flying upside down from air to air. This was really big fun. In order to smoothen up the transition, I think it's important that this front cover doesn't open that much, because it is a very big wind resistant, like an air brake. I think this was normally open up this way. No, we go at this way. I just was using one hole lower on the servo arm, so we have less travel. And I think the next thing I can do is to cut in here, make a big cutout in there, that the air isn't trapped. When the air comes from the front, it is completely trapped under the cover. And we got a big resistance, big air brake. And we see here on the rear cover, we already realized this. Here is a big gap, so when the air comes from the front, the air could easily run underneath here, so that we don't have this big spoiler effect. And also we put some cutouts, made some cutouts here. This is more that a fan gets enough air. And I think for the moment I just do this cutout, and when we got more time we will make a nice CAD solution and put it on the website. So here we got the cover. We can see here there's a lot of things going on. This is the attachment for the lever, and here we got both hinges. So I will cut along this line and along the hinges. This will give us a big cutout. I'm using this hot. Here this wiping back and forth helps a bit to cut through the super glue, which is along these two arms. Okay, here we are. A big cutout. Just for the moment to test it. Later on I think also some nice cutouts will be done in here, like on the rear. But let's see if the transition works more smoothly. This footage here is from the day before I did the changes on this front cover. So this is with the original position, and we were trying to get some nice footage. The sun was also in a perfect position, and yeah, this were my first flights this year, so I also give myself a little bit training to get comfortable again with this airplane. And I think here we just did vertical takeoff, then one pattern and stop in the air, and I was reaching I think 3 to 5 or 4 to 5 complete VTOL pattern. So one complete VTOL pattern consumes just under 1 amp from the battery. That has 4.2 amps. So I think maximum 6 would be possible, but I always keep my safety margin high. I land not under 40% rest capacity. So 4 VTOL pattern is absolutely possible with enough safety. And yeah, it was getting darker and darker, but also the weather became much more calm, so it was even more fun to fly the VTOL jet. And you can see I did the back transition in really low level. I think this was about 10 meter, and there's just no height loss on the back transition. So I think it could be done much lower. But also here I want to keep it safe for the first flight day. Yeah, and this is just a wonderful jet, and it was wonderful weather, and David and Henry were chasing me with the drones. Yeah, and I think we really get a good catch of the JRM VTOL, and yeah, I almost reached my green carpet, so everything runs like it should. And it was again a just wonderful flight day with the JRM 1 VTOL. For the back transition, I approach with about 20% throttle. Then I click the transition button, and immediately I give about I think 50% throttle, and then I take a look if the sink rate is too high, so I get up to about 70% to keep the height, or control my sink rate. And here I was doing it's an in-air touch and go, so just stopping and then go around. And for this, I give 100% throttle and go to normal flight again. And then flying here is about I think with 40 to 50% throttle. I think here I'm coming in again, so you can see there are really, I think, yeah, maximum 5. I think I did maximum 5 in-air stops with landing, so 5 complete VTOL pattern. So there is really enough power on board. So it would be also possible to use a smaller battery to keep the jet a little bit more lightweight. And the flight time I reached here just with this VTOL flying, I think this was 4 minutes. So if you do just one vertical takeoff and then normal flight with normal landing, 8 minutes is absolutely possible. Yeah, and we try to get closer and closer to the drones. Yeah, and this is the day where I was using the first time the changed cover with this cutout and a little bit lower position to smoothen up the transition. Let's see how it works. Also here I was installing some wool strands, but not all around because of these strong propellers. They shouldn't go sucked in. And we can see the transition. I think it goes much faster, already much faster. Even this was again a very windy day where a lot of engine is just used to keep the position and to climb. When it's windy, you need much more energy for climbing because the air is more rough and all the motors are do a lot of stabilization work. But nevertheless, this works super nice. And here, while normal flight, you can see all the strands are nicely aligned, just beside on the strakes. But this is super normal. There we got some vortices, which help to keep the airflow on the wing alive. So this is the reason why you see these two strands just in front of the wing, just a little bit wobbling. This is super normal. Yeah, and here I'm coming back for the back transition, also low level, about I think 7 meter. To save some energy, as lower you do your back transition, as less energy you need for a complete landing. And when you get comfortable with the whole technique, there is really no reason to not do your back transition in this low level. This is not more unsafe or safe when you go higher, so there's really no difference. But I would really recommend you do your first transitions quite high, yeah. And when everything works perfect, you can go with the outbound transition. I think from about 30 meter. Check how it works, and then you can go step by step lower, and the same with the inbound transition. So results from the first flight. I think the outbound was a little bit smoother, but nevertheless the cutout from the front hatch will be made a bit bigger to lower the resistance from the wind. But nevertheless, I'm quite happy also with the onboard footage. Let's go on for the next flight. And always nice to see a turbine jet here from my buddy Bernd. I think this is a 40 Kingfish, and this was the first flight, his first flight with this Delta, and this thing is really fast. And here I'm going to do the outbound transition also a little bit lower. I think this was just 15 meter. So I go step by step closer to the ground. But again, I really recommend you start in higher levels, so about 30 meter, and then check out if everything works nice. And then you can do it more to the ground when you feel comfortable. And I think here I'm going to do some acrobatics. Yes, I think here I try looping. I think this was a little bit too slow. Jet starts stalling me in between. So I think I came back for landing. And of course always land against the wind. It's the same like you do a normal takeoff from the ground. Always start and landing with a headwind. This is absolutely important to keep it safe. Also the vertical steps to stabilize the jet on the yaw axle naturally when you keep the nose into the wind. Yeah, and here I think this was the last start for the day. And yeah, there was really a lot of headwinds, so the climbing up takes a little bit longer. Yeah, this you really have to calculate when it's really windy. You need longer for climbing, for vertical climb, so also more engine consumption. So always have a look on your capacity. Yeah, I really recommend to use some telemetry to keep up with your capacity. So always be sure you have enough for vertical takeoff. Of course, if the battery is low, yeah, there is no way to land safety for the vertical thing. Gliding is absolutely no problem. Yeah, when there should be some problem with the battery, you can glide for landing. Yeah, and here I'm doing again some acrobatics again. Have some fun, flying upside down. Everything is absolutely possible with the JM1 VTOL. Here I'm also checking the stall behavior, and you can see this is not so polite like the X-Wing. The X-Wing, this is yeah, much easier to stall, but also not easy to spin. So the JM1 is more for acrobatics. Yeah, but nevertheless also easy to fly. And here you see I fly always a bit in front of my carpet, and then I can drift back with the headwind. Yeah, this is for really less engine consumption. The new front cover you will find on our website. Just go here to PDF downloads and then scroll down, and here we will provide the latest parts. I think this is here. Update parts for our JRM jets. Yeah, I think next week we will finish the new front cover, and you can download it here for free, of course. So, and if you're interested in our models, just check them out. Here we have a comparison page where you can see all the differences, also the most interesting parts, the printer size and the materials, the channels you need. You will find here on the comparison page. And here you find our JRM series, our jets, then our microcruisers, the small FPV drones, and of course our box wing. So check it out, and if you like to support our projects, you can also become a Patreon. There we will share a lot of behind the screens footage, and also if you purchase our models, this helps a lot to create some new ones and to go on with this wonderful print hobby. Yeah, that's for this video, and see you in the next one. Bye bye.